I can't believe I'm having to show this to grown men.
No, if three people are on top of mountains observing each other, you can't have a triangle with more than 180 degrees. Okay, so this is a little mountain here, and this is a little mountain here, and this is a little mountain here. And you're going to tell me that the three people on top of these are going to measure a spherical excess. But if they're measuring to each other, then they're just going to have three straight lines. And it's impossible that this triangle would ever have more than 180 degrees. If you're on the surface of a sphere, then if you measured a triangle, you would have more than 180 degrees. But that's not where they were. They were on top of mountains. So the line that you draw between another person is a straight line. It's not on a sphere.
But yeah, I've literally had to demonstrate a triangle. 3 points in free space are coplanar. Then they make a 180-degree triangle. I can raise the string on one of them sticks and lower it on another. I'll just change the orientation of the triangle. So with line of sight from each station, I'm only going to measure the angle to the other two stations. Unless I tell it I've changed orientation, then it's going to give me 180 degrees unless I invoke excess.
This is just a quick video to explore angles between points in a couple of scenarios, and I'm going to start with this flat plane. This is alpha, this is beta, and this is gamma. And I get no prize for knowing that these angles add up to 180 degrees. As Bev would say,
the Earth is not flat.
So I'll introduce a bunch of hills and trees that will initially block my view until I can build myself some towers that would elevate me above all of that. Then I could try measuring some angles to each of these new red points that are directly above the black ones. This is alpha, this is beta, and this is gamma, and I can see that these also sum 180 degrees. One thing I notice is that each angle differs slightly to the true values, and I think that's because I've inadvertently introduced a vertical component, or tilt, to each angle that wasn't there before. What do you think? I think this element is unwanted, so maybe I could try eliminating it by just measuring horizontally, i.e. between the towers. Now this is alpha, this is beta, and this is gamma. These angles also sum to 180, and it's good to know that they match the true angles perfectly. Now I'll try this again, but this time I'll use a surface that will curve consistent with that of the globe Earth. Joining each point together with lines that are confined to the surface, we get a spherical triangle. And I can see this time these angles sum to slightly more than 180 degrees. Again, I can lift myself up above the surroundings and I'll try measuring line of sight to each point. And it comes as no surprise to me that Geogebra returns an angle sum of exactly 180 degrees. But as I established before, this is not the way to measure the separation because of that unwanted vertical component. Measuring horizontally between the towers then, this is alpha, this is beta, and this is gamma. And now I see these three regular angles are a match for the angles in the spherical triangle. So if in reality we always measure exactly 180 degrees, then that would suggest that the world is flat.
It's not flat.
But if we consistently measure in excess of 180 degrees, even if it's just a fraction of 1 arc second, then would that validate the globe? Let me know what you think.
So one last thing, let me make a prediction. This is what they do with every other so-called globe proof. Is when I finally call them out, when I finally pin them down and get them to respond to this, they'll say, well, we already know the Earth's a sphere. So we know the orientation changed. So yeah, they are measuring spherical excess. Instead of being honest, telling the people that it's assumed the orientation changed, not measured, they'll act like that was a given the whole entire time. It's a joke, man. So can you please be honest, Globers? But I wouldn't hold your breath.
It's not flat.